Welcome to the deep dive. Ready to explore something pretty cool?
I'm always up for cool exploration.
Perfect, because today we're going to dive deep into the world of reinforcement learning. You might know it as RL.
Yes. RL, a fascinating area.
Absolutely. And our guide for this deep dive, a podcast episode called 9 Minutes. They do a great job breaking down complex tech topics.
I've heard good things about that one. So RL, huh?
Where do we even begin?
Well, you can think of RL kind of like training a dog.
Like training a dog. Okay, I'm intrigued.
But instead of teaching him to fetch, we're teaching machines to do some pretty amazing things.
I see. So it's about teaching, or rather, machines learning.
Exactly. And that's where the reinforcement part comes in.
Right, reinforcement. So how does that work with machines?
Well, in RL, we have something called an agent. Think of it like our digital student.
Okay, the agent. Got it.
And this agent lives in an environment, basically the world where it operates.
So the environment could be anything. Pretty much. It could be a simulated world, like a video game, or a real-world setting.
Interesting. So what does our agent do in this environment?
It takes actions. These are all the possible things it can do. Like, if the environment is a video game, the actions might be things like moving the character, jumping, or firing a weapon.
So it's like the agent is interacting with its environment.
Exactly. And each action leads to a certain outcome. And based on those outcomes, the agent receives rewards.
Rewards. Now, those are important.
Definitely. Rewards tell the agent whether its actions were good or bad. Kind of like scoring points in a game.
Oh, I see. The higher the score, the better the actions.
Yeah, you got it. And the whole point of RL is for the agent to figure out how to maximize its rewards over time. It's all about learning through experience.
Just like that dog, learning which behaviors get the most treats.
That's a great way to put it. But instead of treats, we're talking about achieving a specific goal within its environment.
Makes sense. So how does this learning through experience actually happen?
Well, through all these actions and rewards, the agent develops something called a policy.
Policy, what's that?
Basically, it's the agent's strategy, its game plan for getting those rewards.
Ah, I see. So it's not just reacting randomly, it's learning and adapting.
Exactly. And the key to learning a good policy is finding the right balance between two things: exploration and exploitation.
Exploration and exploitation. Can you elaborate on those?
Sure. Exploration means trying new things, even if they might not work out right away.
And exploitation.
Exploitation means sticking with what already works, what's known to get rewards.
So it's like, should I stick with my favorite pizza place or try that new one down the street?
That's a perfect analogy. Too much exploration, and you might waste a lot of time on bad pizzas. Too much exploitation, and you might miss out on an amazing new discovery.
And in RL, the agent has to find that balance to learn effectively.
Exactly. It's a delicate dance between trying new things and using what's already known to work.
I can see how that would be crucial for the learning process. So we've talked about games and dogs, but where does this RL magic actually show up in the real world?
Oh, you're gonna love this. RL is already making waves in so many different fields. We're talking robotics, finance, even things like personalized recommendations on platforms like Netflix.
Wait, hold on. RL is behind those Netflix recommendations.
You bet. We'll dive into all of that right after a quick break.
Can't wait.
And we're back. Still diving deep into the world of reinforcement learning.
Where we left off was pretty interesting, that whole exploration versus exploitation thing.
Right. It's like a constant tug of war for these RL agents.
Exactly. They need to strike that perfect balance between trying new things and sticking with what they know works.
I'm curious, how do researchers actually design these RL algorithms to handle this?
Well, one common method is something called epsilon greedy exploration.
Epsilon greedy. Sounds a bit technical.
It's actually a pretty simple idea, despite the fancy name. Imagine flipping a weighted coin, right?
Okay, I'm picturing it. Weighted coin. Got it.
So sometimes the coin lands on exploit. The agent uses what it already knows. Other times it lands on explore and it tries a random action just to see what happens.
So it's like sometimes you play it safe and sometimes you take a gamble.
Exactly. And the weight of the coin, or how often it lands on explore versus exploit, that's controlled by this parameter called epsilon.
I see. So at the beginning, when the agent doesn't know much, you'd want it to explore more, right?
Right. So epsilon starts high, meaning more exploration. Then, as the agent learns and gains experience, epsilon gradually decreases, shifting the balance towards exploitation.
Makes sense. The more it learns, the more it can rely on what it knows.
Precisely. And of course, there are other more sophisticated methods for handling this dilemma, but epsilon greedy is a good starting point.
So we've got this balancing act, we've got the data issue. Anything else that makes RL tricky to implement?
Oh yeah, definitely. There's this thing called the curse of dimensionality, and it can be a real headache.
Curse of dimensionality. That sounds ominous.
It is. Think about it like this. The more complex an environment gets, the more possible states and actions there are for the agent.
So, more possibilities, more complexity. What's the curse?
The curse is that the number of possibilities explodes. It grows exponentially with the complexity of the environment.
Ah, I see. It's
Yeah.
like if you have a simple maze, it's easy to find your way out. But if it's super complex with tons of branching paths.
Exactly. It becomes much, much harder to explore and learn the best route. And in really complex environments, like imagine a self-driving car in a city.
Oh, wow. Yeah, so many variables. Other
Oh.
cars, pedestrians, weather.
The number of possible states and actions becomes astronomical.
Hmm.
And that makes it really tough for an RL agent to learn effectively.
That makes sense. So how do researchers deal with this curse? Is it even possible?
It is, but it requires some clever techniques. One common approach is function approximation.
Okay, function approximation, what's that?
Basically, instead of trying to learn the exact value of every single state action pair, which is impossible in really complex environments, the agent learns a function that can estimate those values.
So it's like a shortcut. Instead of calculating everything directly, it uses this function to get a pretty good idea.
Exactly. It simplifies things a lot and makes the learning process way more manageable.
That's pretty smart. Any other techniques they use?
And another interesting one is hierarchical reinforcement learning.
Hierarchical, like a hierarchy of tasks.
You got it. Instead of trying to learn this huge, complex task all at once, they break it down into smaller, hierarchical subtasks.
So it's like instead of learning to cook an entire meal, you first learn to chop vegetables, then boil water, and so on.
A perfect analogy. Each subtask is easier to learn, and then you can combine those skills to tackle the bigger task.
That makes the whole learning process a lot less daunting.
Right. And it also allows the agent to be more flexible. Like, let's say you've taught a robot to clean the kitchen, but now you want it to do laundry.
Okay, so it already knows how to pick things up, move around, stuff like that.
Exactly. So it can leverage those skills it's already learned and apply them to this new task.
So hierarchical RL, it's not just about simplifying learning, it's also about adaptability.
You got it. And these are just a couple of examples of how researchers are tackling these big challenges in RL.
It's amazing how creative they have to be.
It is. And, all this work is paying off.
Yeah,
RL is already having a real impact out there in the world.
it's true. And I'm sure it's only going to get more influential in the future.
Oh, absolutely. RL is still young, but it's got a ton of potential.
Well, after the break, let's dive into that future, shall we? What breakthroughs are on the horizon for RL? What's next for this amazing field?
Let's do it.
Back again. Ready to wrap up our deep dive into the world of reinforcement learning?
Absolutely. It's been quite a journey.
It has, from the basics to, wow, those challenges they face. It's amazing how much progress researchers have made.
It really is.
Yeah.
And the future of RL, well, let's just say it's looking pretty bright.
Yeah. Okay, so spill the beans. What exciting developments are on the horizon? What's next for RL?
Well, you know how we talked about those challenges, the data hunger, designing those reward signals, that curse of dimensionality.
Yeah, they definitely sounded like some major hurdles.
Well, researchers are working hard to develop algorithms that can overcome these hurdles. Algorithms that are more robust, more adaptable.
So basically, algorithms that can learn more efficiently and handle even tougher situations.
Exactly. Imagine RL agents that can take what they've learned and apply it to completely new situations they've never encountered before.
Wow, yeah. Like if a self-driving car could not only navigate the roads it was trained on, but any road, anywhere in the world.
That's the kind of adaptability we're talking about.
Yeah.
And another exciting direction, developing RL agents that are more, human-like.
More human-like. In what sense?
Well, think about it. Current RL agents are great at optimizing for a specific goal, right? But they don't always have that common sense, that intuitive understanding of the world that we humans have.
It's like they can master a game, but they don't really get what's going on at a deeper level.
Exactly. So researchers are trying to figure out how to build RL agents that can reason about the world more like we do.
So they wouldn't just blindly follow reward signals. They'd actually be able to understand why things happen and what the consequences of their actions might be.
Precisely. They'd have more common sense, be able to make better decisions in complex situations.
That's incredible. It's like we're talking about an AI that's not just intelligent, but actually insightful.
And, it's not just about developing better algorithms. Another big trend is the integration of RL with other AI techniques.
So like combining the power of RL with things like natural language processing or computer vision.
Exactly. Imagine an AI assistant that can understand your commands, but also learns your preferences over time thanks to RL.
Wow. It would be like having a personal assistant that gets to know you better and better the more you interact with it.
That's the idea. And that's just one example. The possibilities are endless when you start combining RL with these other powerful AI tools.
This has been an amazing deep dive. I feel like we've only scratched the surface of what RL is all about.
It's true, there's so much more to explore. But hopefully this has given everyone a good taste of what this fascinating field has to offer.
Absolutely. And who knows what incredible breakthroughs we'll see in the years to come.
The future of RL is bright, that's for sure. And it's a future that we can all be a part of by staying curious, asking questions, and imagining the possibilities.
Thanks for joining us on this deep dive into the world of reinforcement learning. Until next time.